This is question 33 of civil engineering paper of GATE 2018 afternoon session. Three soil specimens, soil 1, soil 2 and soil 3, each 150 mm long and 100 mm diameter, are placed in series in a constant head flow setup as shown in the figure. Suitable screens are provided at the boundaries of the specimen to keep them intact. The values of coefficient of permeability of soil 1, soil 2 and soil 3 are 0.01, 0.003 and 0.03 centimeter per second respectively. The value of H in the setup is. So, in this question a constant head flow setup is given which contains the three soil samples, soil 1, soil 2, soil 3. The cross sections of all the soil sample is given and it is same. The length is 150 mm long and diameter is 100 millimeter. Now, the head at soil 1 is given as 560 mm and head at soil 3 is given as H. We need to find this value of H. Now, the permeability of all the soil samples, soil 1, soil 2 and soil 3 are given, as you can see 0.01, 0.003 and 0.03 centimeter per second respectively. So, this question is from the topic of permeability of stratified soils. You may study in details about this permeability of stratified soils in lecture 9, permeability and seepage, soil mechanics, geotechnical engineering 1 by Professor Dilip Kumar Baid, IIT Kharagpur. So, in the stratified soils there are two conditions. If the flow is horizontal, that is parallel to the bedding planes, and the second condition, the flow is vertical, that is normal to the bedding plane. Now, in this question you may see the flow is perpendicular to this bedding plane of the soil. So, you can say the condition is for vertical flow. So, we can find the equivalent permeability. We can find the equivalent permeability Kv by this formula, by using this formula. So, this one summation of H divided by summation of H by K. So, here this the length of soil 1, soil 2 and soil 3 is given as 150 mm. So, here the permeability is given in the units of centimeter per second. So, it is better to convert all the units in centimeter. Always remember to keep all the units uniform. So, just write all this length in centimeter. So, the length is 150 mm, that is 15 centimeter. So, this one H1 plus H2 plus H3, that is 15 plus 15 plus 15 divided by H1 by K1. So, H1 is 15 divided by K1. So, the K1 is given as 0.01, 0.01 plus H2, H2 is again 15 centimeter divided by K2. So, the K2 is 0.003, 0.003 plus 15 divided by K3. So, K3 is 0.03, 0.03. So, when we solve this, we will get the Kv as 9 by 1400 centimeter per second. Now, this is the equivalent permeability for this condition for all the soils. Now, if the discharge through soil 1 is Q1 and discharge through soil 2 is Q2 and discharge through soil 3 is Q3 and the net discharge throughout through all the sample is Q, if this is Q. Okay. So, we may write this Q will be equal to Q1 is equal to Q2 equal to Q3, that is the discharge through all the samples and the net discharge through this constant head flow setup will be same. So, now the net discharge through this setup will be Q. So, we know the formula of discharge by Darcy's law. We know the Darcy's law, Q equal to K I A, where Q is the discharge, K is the permeability, I is the hydraulic gradient, which is equal to the head causing the flow divided by length of the soil specimen. A is the cross section area. Now we can we can write the equation Q equal to Q3. So by using this equation, if we write the net discharge through this setup, we may write this equivalent this KIA. So this KV I into A, okay, is equal to, so this is I for you can say equivalent, I equivalent. Now Q3, again Q3, so it will be K3 into I3 into the cross section area A. Since here you can see the cross section of all the soil samples are same, and the cross section of this setup of containing all the soil layer are same. So we can say the in both the equation this A will be same. Now we can write this KV, the value of KV we got 9 by 1400, 9 by 1400 into hydraulic gradient, equivalent hydraulic gradient will be the head difference from soil 1 to soil 3. So we can say 560. So head causing flow here will be 560 mm. So it will be 56 centimeter H by length. So length will be this 15 plus 15 plus 15. So 15 plus 15 plus 15, it is 45. Now area, so area A. Now K3, so we have the value of K3 as 0.03, 0.03. Now I3, so I3 means hydraulic gradient at soil 3, so this will be H. The head causing flow in soil 3 will be H, so this will be H divided by length of the soil specimen, that is 15 centimeter, into A. Since the cross section area is same in both the equations, so A will be cancelled out. Now if we solve this equation, we will get H as 4 centimeter. Now in this question the options are given in millimeter, so we can write this H will be 40 millimeter. Now so we can say you can see 40 millimeter in option B. So option B is the correct answer for this question. Thank you.